The work I have to deal with here is a standard level piece of content, which is an introduction to one variable statistics and how this particular piece of content can relate to the wider chapter in some of the IB courses, or the wider context in IB courses. And it's very important that we bring into these contexts the idea of TOK and also the idea of the exploration. So some of the maths we should be doing is helping students think about what they could use for the exploration. So I tried to bring this into the presentation here as well. So in my experience, it's clear that a lot of students struggle with the words and terminology in the statistical context. All right, so they find it very difficult to sometimes distinguish between when is something a population, when is something a sample, and how do we distinguish between the two, and when we apply statistical techniques, how do we deal with each of those in a different way. So that's quite an important idea, that the students know the difference between some of these concepts and also are able to use the terminology correctly. So I've tried to also bring in a TOK option here as well, where we might discuss in class what is meant by bias. If we have a bunch of statistics, how do we know if there's bias or not? In what context will we find bias? How do we know statistics are biased or not? Are they fake? Have the statistics been generated by a sort of a fake news type of process? So that could open up quite a lot of discussion on TOK. So in the next slide, I just want to go on a little bit about the statistics terminology and try and bring in the idea of the exploration. So what I want people to think about, or students to think about, is how they can use ideas that we come across in the work to maybe set up an exploration that they could carry out some sort of experiment, collect data, discuss any bias in the collection of the data, any problems or issues with the collection of the data. So this could be something that they could use, especially at standard level, to make a suitable exploration using stats, because there's so much we can do and so many mathematical procedures we can use for stats. So we'd have to be clear that students know what a parameter is, they have to know what a statistic is, they have to know what it means when we say a distribution. All right, what does that mean? Okay, and they would also need to know quite a lot about outliers, because that can create quite an interesting sort of TOK discussion as well. When is something an outlier? When isn't it an outlier? How do we know whether something is an outlier? So it's very important they understand some of the terminology and techniques that we've come across. They would also need to know types of data, discrete data, continuous data, and this will open up discussions what things in statistics are discrete, what things in statistics are continuous, how do we distinguish between the two, and can we use that sort of information successfully, maybe in a TOK discussion or in a exploration. So the key thing here, I think, is to make sure that students don't just see statistics as something that you're just doing in a textbook in a classroom, that you're trying to make them see that you can apply it to the real world. So if you look at this example over here, here's a real world problem with a whole lot of statistics, and I'd ask the students to think about those statistics and maybe make a few points about what's difficult about seeing all those numbers. What should we do to make that data more accessible? And I think that's something that they're going to come across often in the real world. How do you take a bunch of data, a distribution, how do you sort it out and make it accessible to someone else? So that's what we'll try and investigate in the next few slides. So with the previous slide, I'm trying to introduce the idea of a data cycle. I'd get the students to pose a question on the P experiment. All right. I'd try and bring in some ideas of how they could use something similar to this for an exploration or a practice exploration that we could mark. I'd get them to write an investigative question around that real world problem that we saw. I'd ask them how we're going to organize the data, how we're going to display the data, how we're going to summarize it, and how we're going to analyze it, and how we're going to make a conclusion. So these points over here, I plan to get a whole lot of student discussion going so that we can see exactly what is going on. And so they can give their own answers as to how they would do these things. And so hopefully out of this will come all the technical graphs and numbers and terminology that we need in the data cycle or in an exploration even. So in the next slide, I'll try and get the students to think about how will we process a large number of data. And so hopefully from asking that question, somebody will come up with, why don't we organize it into a table? Maybe they'll give me some reasons for that. And then I'll ask them to try and work out what things can we put in the headings of the table here to make the data more organized. What goes in this column, what goes in this column, what goes in this column, and what can we do with this table to organize and process the data. So a lot of students might not even know that you can put data into a table, even at IB level. So that's what we get some sort of classroom discussion going on that. And then we could use their answers or their attempts to see that when we set up a table, things like mean, median, range, and mode, these basic techniques, these become a little bit more obvious. All right. And then also once we've got data organized a little bit more, we could also bring in the TOK aspects of it and say, well, which central tendencies make sense in this context? Which one shall we use? Mean, median, mode, and why? Okay. Are there outliers? Why are there outliers? Can we ignore the outliers? What is the effect of an outlier? So all of those sort of things come into sort of these reflective processes. How do we know particular bits of information in maths? So, and we'd use that table also to make a connection into the graphic calculator where we can put two lists with values and frequency, and then you work out one variable stats from the graphic calculator. But that on its own can't be done sort of willy-nilly and very quickly in class. You would probably need to take several lessons, or a lesson at least, where they're entering data, fiddling around data, so they can use the calculator to do all the donkey work. So that would be my plan. That would be one of the things we could develop from this lesson, is a whole lot of lessons on basic calculator skills using statistics. So because these can be used quite nicely in exploration as well. Those screen dumps can be pasted in there. All right, just carrying on a little bit more. Once we've got a whole lot of data organized to some extent, we will then need to display it. And again, a TOK question, sort of, why is it necessary to display data? Why is it a good idea to do that? And that hopefully we get some interesting discussions on how we know things. Okay, we can use bar charts on Excel. We can use a very nice web-based program called New Zealand Grapher, which enables us to make a lot of graphs and calculations without having to download anything. We can use that particular web-based function to make graphs and documents that we can paste into an exploration. So this is quite an important one. I'd like students to be able to fiddle around with that. They can even use Desmos if they need to. So once we've got a bunch of displays, okay, we can try and analyze which display is best, what's the difference between the displays, and that sort of links up quite nicely with the TOK and an exploration. I've given a sort of worked example here that I'd go through with the students so they can see exactly how to set up a table, and once they've got a bunch of data like this, how they set up classes, okay, to make a frequency table, and then work out things like the modal class and describe the distribution of the data. So this would probably work through together in class, asking them to choose classes and then discuss which classes work and which don't. All right, so once I've gone through those basics, talking about things like making classes, things like setting up a frequency table like this, things like graphing them using New Zealand Grapher or a spreadsheet, then it's time to practice, and we could make them see how these graphs derive from this table, and also on the graphic calculator, how do we calculate a mean of this data? So we'd have to discuss how we're going to choose stuff that we can use on the graphic calculator, because we don't know all the bits of data here. So that could open up quite a lot of interesting discussion. So it's very important that students practice this stuff, and this could be done in class or online or projected, and they could work through this in class. Okay, so in the next slide, we're going to do a few more examples, similar sort of thing, and then quite a nice one over here to analyze a histogram. What's the difference between a histogram and a bar chart? What makes a histogram more difficult to interpret? And the fact that New Zealand Grapher can help us with a thing like this to overlay certain things like a normal distribution onto a histogram like that for sort of further, more in-depth analysis. So lots of practice examples needed here. Then I've also selected a couple of basic, some of these are very basic video reviews, so students could look through a couple of these videos just to make sure they've got the basics under control, and see how to draw. I think in one of these, how to set up and draw manually a histogram. They could practice it on a spreadsheet or on their graphic calculator even. But again, as I said, that would need several discrete lessons for use of the graphic calculator. Very difficult to sort of integrate it very quickly into a lesson where you are dealing with some basic concepts. You need to do it separately, I think. So again, this is the power of something like New Zealand Graphic. Can make a nice histogram for you from a built-in data set. You can overlay stuff, various graphs or curves or distributions onto that particular histogram. You can change the width of the classes for maybe a better view, to give a better overlay of things like a normal distribution. So this is quite useful, and you can see the ability of a student to cut and paste this into an exploration. It makes nice, clear graphics that he can talk about and reflect upon. Okay, so I've made a clear point about the TOK input, and I think it's very important that students think about how they could use TOK and exploration type thought processes in this topic. So I get feedback from the class here, and let's think about 5 ways where we could set up a statistical investigation or context and collect the data. So that could open up quite a lot of discussion on how we could maybe, if you look at something like the bag weights of year 12 students, or the distance or time for students to get to school. This gives a lot of options where we could collect, organize, display, calculate a whole bunch of statistical values for a project. So hopefully that will be very meaningful to the students. Then I also want to be clear that the TOK needs to be permeated through maths. A lot of teachers don't really link up the maths that they're teaching in the diploma with the theory of knowledge core course. So we'd have to have at some point a little discussion on, is statistics real mathematics? Is statistics and probability, is it pure enough mathematically wise? Can we manipulate stats to show a predetermined result? Does fake news generate statistics that we can find fault with? And does processing and organizing statistics help us to know more about a particular context? So I'm hoping that we could get quite an interesting TOK discussion developing through this concept. Then also we've got something that we could use like random numbers and statistics, again bringing in the TOK aspects. And I'd like to think that reading through an article like this, having students jot down some key points and make them think about generating numbers, random numbers to help them in statistics. Can they sort of use their TOK techniques to make sense of that topic? Can they use TOK to help them understand better what is going on in statistics and in probability? So that's the key thing, is to make sure that we are indicating to students that there are exploration ideas in this work, and we are indicating to students, and the exploration doesn't have to be hugely cerebral, in my opinion. It needs to be something that the student owns, that the student does on their own. So setting up an experiment, collecting a lot of data, processing, organizing, displaying that data, writing reflective comments on it, maybe doing the experiment again, using advanced skills like a normal distribution once we get there. This particular topic lends itself to students who maybe are not that good at pure mathematics, but are quite good at sort of applying the maths to a real world problem. And so I think this is quite an important aspect that we don't want to lose sight of when we present mathematics in the diploma, where we just maybe too exam focused, when we're not using the opportunities that we're given here for TOK and for an exploration. So that's what I'd like to encourage students to do, is to make sure that they can use what we're covering in class for those two sort of key core topics. So again, this piece of work that I've spoken about here, this lesson is probably enough for 2 or 3 lessons as an introduction. It gives scope for TOK discussion. It gives quite a lot of scope for how we could set up a exploration and how students could use the techniques we're going to discuss to make that exploration more meaningful or make it relevant to the real world. And if we students will write something that is clearly their own, that they've done on their own, that they've collected, rather than just rehashing someone else's statistics. So I think it's very important to make that point to our students, that we do have all these options available, even while we're doing some maths that may be, well, not too difficult, but certainly in my experience, students have struggled with some of the concepts here, and we need to make them very, very clear what sort of things we're talking about.